Hello everyone. So in the last video we have had a look on variables and how we can use variables, how we can declare and initialize values to the variables, and yes, how we can use it. And even we used a variable name called x, and we have even blinked an LED using that variable name, right? So I have talked a lot of things in the last I think 2-3 videos. So if you didn't watch them, please go watch them and come back to the video. Otherwise it will be a little bit confusing, because this video is a continuity of this last let's say 2 or 3 videos. So now you know, if we are going to use a variable, we have a structure, right? Data type, variable name, and equal to variable value. And also I said you this is called variable declaration and initialization. And also I said this thing, whatever is in the left side is called declaration, and what is in the right side, that means the assigning of value to the variable, is called initialization. That means giving a value to the variable. Okay. And also I talked about something using the Paint software. I drew let's say a picture of memory location. So what actually happens when we are creating a variable and assigning a value? So let's forget about this. Come on quickly. Okay, so we give a name to the variable and we store a value here. So I stored number 7 at the initial using x. We have done so many things. So let's talk about something here, something important now. So this variable declaration and initialization I have done in one line. Okay, so what if we have to tell a variable name, okay, or in another word, what if we can use the declaration and initialization separately, if there is a possibility or not? Yes, there is an absolute possibility. That means you can do the variable declaration in one place, okay, and variable initialization in another place. Okay, and I want to tell you, okay, let's forget about that. Okay, just first come to the point. Okay, so what is the declaration thing? This part, right? I say it. So variable declaration will be mentioning the data type and the name. And also, since even though you are separating this, I told you at the end of every line every command or end of everything we are telling to Arduino we are supposed to have a semicolon. Since we are separating this declaration and initialization, declaration now comes as a single line, right? Earlier we wrote it both together as the same line. Now declaration will be in a line, initialization will be in another line. So since this is a single line and declaration itself a command, that means we are saying we have a variable with this data type. Okay, so since declaration itself is a command, we will be having a semicolon as usual. Okay, and then initialization can be done. It doesn't have to be done in the next line. It can be done anywhere you want. Okay, it is not a must to do immediately, but declaration is a must to be done at the initial state or beginning state. Okay, so initialization, what I will do is I have to assign the value to the variable, right? So what we have to do is we have to take the name and the value and assign here. So we will do like this: name equal to whatever the value you want to keep. You can do like this. This is totally okay. Okay, so this is one line thing. This is separate line thing. Okay, so I already said you we can change the value of the variables, right, manually during any time. Okay, that is the purpose of the variable. That means something that can vary in the value, right? Okay, that's fine, let it be that way. So let's take an example of x. Okay, so earlier when we are doing everything together, okay, for a number, okay, for an integer type, earlier what we had is int x is equal to 7. Is that correct or not? It's correct. Variable data type, name and value. So that means we have an integer number. That number is stored in a memory location, and the name of the memory location is x, or the variable is x, and the value we are assigning to x is 7. So exactly this thing will happen. Now what I am telling you is we will separate this, okay, in 2 lines. Okay, so first I am going to do the declaration in one line and initialization in another line. So you know the data type and name should be coming. So data type is int and name is x. Okay, we can write like this. So that means we are telling the Arduino we have a integer that is called x, but I am not assigning the memory now. I am not assigning the value now. I will assign the value later. Just remember there's an integer called x. Okay, so when you are saying like this, what will actually happen is okay, so I will remove this thing. Okay, I will restart this thing by erasing this. Okay, what will actually happen is the program will go and find a memory location first and name it as x, because I have already said I am going to have a variable that's called x. Okay, I'm going to have a variable x. Okay, so program will come and name a memory location as x, but we don't have a value to store here because I didn't tell it. I only did the declaration. So there is something called default values. Okay, default values. So what the program will do is, okay, he said integer x, okay, that's fine, but he didn't assign a value. Okay, so let's take the default value for the integer data type, because x is an integer data type, right? X is the name you are giving, data type is integer. Okay, so the Arduino will think, okay, integer data type, what is the default value for the integer data type? He will go and check, and then he will store the value here, okay, in that memory location. So please guys, get to know that default value of an integer data type is 0. Okay, that means if you don't assign a value to a particular integer data type variable, the program will itself assign 0 to this, or in other words, the memory location program will have 0. Okay, just don't worry about that. 0 will be stored here, and whenever you are assigning a value to this variable somewhere else, this 0 will be replaced by the value. Simple as that. Okay, so let's say in another line, please remember guys, this line may not be the next immediate line. It can be anywhere you want to have that assign the value, you can assign, that's totally fine. Okay, so somewhere else you are saying x is equal to 7. Why? The initialization should happen this way: name is equal to value and a semicolon. So you have already said there's an x, please guys, there's an x, please remember, integer. So then somewhere else you are assigning x is equal to 7. You can do this, right? Anywhere you can assign it. That is the benefit of breaking it into 2 pieces. You can assign the x value anywhere. Okay. So the very moment you are doing this, program will go and see where is the memory location x. Okay, x is here. He wants the x is equal to 7. What is the value? Current value now 0. So Arduino will take this away, and Arduino will replace, okay, the 7 at this place. Okay, Arduino will replace the 7 at this place. I'm sorry, at this place. So now 7 will be replaced here. So now whenever you are using x, x will be considered as number 7, integer 7. Okay, wait. One more thing I want to tell, because earlier what we did is we had this x is equal to 7 in one line, and when we had to change, we went and changed manually 12 here, right? Likewise, during the program, okay, throughout the program you can change the x value anywhere you want. For example, if you want to use the pin number 7, okay, so you are declaring x, and if you want to use the pin number 7, you assign x value as 7. Okay, and you can use it for a period of time. Use the x, okay, for few lines, and then you are supposed to use pin number 12. Okay, then you can simply reassign the value to x 12. Okay guys, so this detail we will see in the next video guys. So thanks for watching. Please follow me up in the next video guys. Thank you.